Hello, everyone. This is a review for 5C 6. No, wait, that's 10. 6. All right. So 5C6. Determine the written description of the complement of the given event. When 7 job applicants are examined, none of them test positive. Okay, the complement, the definition of it within statistics, is that at least one of them tests positive. All right, question 2. All right, based on a poll, 60% are more careful, okay, when using a Wi-Fi hotspot. What is the probability that among the 3 randomly selected internet users, at least one, okay, is more careful? All right. So anyway, this is how we solve this. Where'd my calculator go? Hang on just one second. Let me pull it up. There it is. All right, so. All right. So anyway, this is how we solve it. All right. So we have 60%. All right. So we need to take how many are not careful, okay, which is 0.4. 1 minus 0.6 is 0.4. All right. Now, we're going to do that 3 times. Times 0.4 times 0.4 equals, okay, 0.064. All right. So this is the probability of getting people who are not careful, or at least one that's not careful. So now I take 1 minus 0.064, and that is the probability of finding someone out of 3 tries, at least one who's going to be careful. All right. And there we have our answer, 0.936. Now, how is this affected by the additional information? All right. So it is very possible, okay, and this is, how is this result affected by the additional information that the survey subjects volunteered to respond? Okay, this is volunteer, and this is always a problem when you volunteer. It is very possible that the result is not valid, okay, because it may not be representative of the whole. So I would hope that more than 60% were more careful when they were on a public hotspot. Okay, all right. So, because you should always be careful if you're at any restaurant, okay? Make sure you're not checking email, all right? Looking up bank stuff, okay? Those are just places where someone could be in there and have a device or an app or something and be checking to see screens, and if you got one that's not encrypted, or if you're not careful, okay? So anyway, that's for free. All right, question 3. Okay, so the data represents the results of a test of a certain disease. Okay, assume one individual from the group. Okay, so one individual from all of this is selected. Find the probability of getting someone, okay, who tests positive. All right, so someone who tests positive, given that he or she had the disease. All right, and so this would be this whole group right here. All right, so I take let me clear all this out. Okay, so I take 130 1, the amount of people, okay, that tested positive given they had the disease, so it's 131 out of 141. And when we round that, that is 0.929. Okay, so you have to read it properly. Tested positive, okay? All right? So, the people test positive given they have the disease. Okay? Now, okay, you could look at it to see who tests if we went this way, the people that tested positive, okay, and had the disease. So all of these people tested positive. All right? That's why we talk about false negatives, okay, when we do certain testing. All right, so question 4. All right. What's the probability, okay, and it explains all of this up here, okay, that strap people to a polygraph, all right. What's the probability that the subject lied, okay, which is right here, and had a negative test result? Right, well, had a negative test result, that is going to be 9 divided by 53. Oh, I'm sorry. Hang on. Oh, nuts. I just... Sorry, I did that wrong. Okay, so that's the second one. All right. What is the probability, okay, given that the subject lied and had a negative test result? Okay. So negative test results are right here. All right. And the subject lied. Okay. So we take 9 and divide it by 45. All right. 9 divided by 45 equals. Okay. Mine didn't carry out, or I'm sorry, 9 divided by 44. There we go. Okay, that's better. So, given the negative test result, so look at this second part first, okay, and look at your negative test result total. That's 44. That's going to be on the bottom, okay? Given that the subject lied, okay, would be 9. So 9 divided by 44. Okay? Now, the subject lied. Okay, that's where we look at this section. Okay, see? Subject lied. Okay? And it is negative test result. Okay, so 9 out of 53. And that's where we get 0.170. Okay? So, whatever you see in the second part, that's what you have to find up here. So, negative test result. All of these people. Subject lied. All of these people. Okay? Positive test results would be the addition of 18 and 44. Okay? This is when you're looking at the second part. Okay, so you got to look at the second part and then read the first. Whatever's the first is your numerator. Whatever is the second is your denominator. Okay, next one. All right, so identical twins, okay, come from a single egg, and fraternal are from 2. Okay, have to be the same. Okay, so also identical twins must be the same sex, and the sexes are equally likely. And sexes of fraternal twins are equally likely. Excuse me. So, if I take a look at this, all right, after having a sonogram, a pregnant woman learns that she will have twins. What is the probability of identical twins? Okay, so here are all the twins. All right, so that's in my denominator. So there's 3, 6, 9, 12, 18, 21. 3, 6, 9, 12. I'm sorry. 3, 6, 9, 12, 15, 18. Okay, I was jumping ahead. All right, I knew it wasn't 21. All right, so there are 6 threes here. So 18. So that's my total. That goes on the denominator. What is the probability that she will have identical twins? Well, 6 out of 18. Divide both by 6 and you get 1/3. Okay? 1/3. After studying the sonogram more closely, the physician tells the pregnant woman she will give birth to twin boys. What is the probability that she will have identical twins? Okay, so twin boys are right here. Here's your total, 6. Okay, what's the probability? 3 out of 6, or 1/2. All right, question 6. Identical twins, okay, they give all the same stuff. If a pregnant woman is told she will give birth to fraternal twins, okay, that is this section right here. So she has fraternal twins, boy, 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 girl, or girl, boy, girl, girl. All right, what is the probability that she will have one child of each sex? Okay, so they will have one child of each sex. So I have 6 and 6 as a total of 12. My total down here is 4 plus 6 is 10, plus 6 is 16, plus 4 is 20. So I have a 12 out of 20. Okay, 12 divided by 20. And that's 0.6, or it has to be reduced to 3/5. Okay, so that is 5C6. And good luck. And if you have any questions, please send me an email, text, whatever. Guys, I'm here for you. I want to see you do this. And again, I can't tell you how badly I want you to finish this, because I know what a help this will be for college come the fall. Alrighty, take care.